When you're flying in the clouds, you really want to have confidence in your navigation systems. You already know about checking the ID and watching for the CDI and the nav flag when you're using VOR. But neither of those checks will tell you when your VOR receiver is out of calibration. A situation where everything looks normal, but your actual position is many radials from the one you're seeing on your CDI. It's hardly acceptable for navigation when you can't see the ground. Fortunately, VOR receivers are very reliable, and you rarely see such errors, but they're still possible. That's why the Aeronautical Information Manual recommends that you have an authorized avionics shop periodically calibrate your VORs. They suggest annually, just like you might have an annual checkup for your vision. But in between those professional checkups, wouldn't it be nice to have a convenient and reliable way to know that your VOR deserves your confidence? Well, want no more, your wish has been granted, and you actually have a number of different ways you can check your VOR's accuracy. Some of these checks can be done on the ground and others in the air. By the way, the FAA also shares your interest in reliable navigation, so much so they have a long-standing requirement that you check your VOR receiver within 30 days before using it for an IFR flight. But experienced instrument pilots consider the 30-day requirement a minimum, and most check their VORs at every convenient opportunity. Since you know why you want to check your VORs, let's talk about how. Your options are dictated by the local facilities. My favorite VOR check, if it's available, is the VOT, or VOR test signal. You'll know if there's a VOT at an airport by looking in the VOR receiver check section in the back of the airport facility directory under VOR test facilities. For instance, at Wichita Mid-Continent Airport, the VOT frequency is 114.0, and you can tell that it's usable anywhere on the airport because it's not restricted in the remarks column. VOTs are usually designated for ground use only. You'll discover if you can use one while airborne from the remarks section. For instance, in the remarks for the Minneapolis-St. Paul International Airport, it says the VOT is usable between 2,500 and 4,000 feet MSL within a 15 nautical mile radius of the VOT. So where else can you find VOT frequencies? You can find them on the communications panel of your en route or area charts. The VOT frequency will be listed with the other communication frequencies, as seen here at Boise. And if you're using Jeppesen charts, the VOT frequency is conveniently shown on the airport chart page. A VOT check is quick and easy. First, tune into the published VOT frequency just like you would any VOR and listen to the audio. You should either hear a series of dots or a continuous tone. Each VOT has one or the other. A VOT acts similar to a normal VOR station, except it only radiates one signal, the 360 radial. So what should you see when you've got that VOT tuned in? The same as if you're on the 360 radial of any VOR. When the needle is centered with a from flag, you should see 360 in the OBS. Now, the FAA allows you an error of plus or minus 4 degrees, so the needle could be centered anywhere from 356 degrees to 004 degrees with a from flag and still be legal. Then, twist the OBS around and center the needle with a 2 indicator. Again, you're allowed an error of plus or minus 4 degrees, so the needle could center anywhere from 176 degrees to 184 degrees with a 2 flag. If you have trouble remembering this, think of Cessna's big brother to the Skyhawk, the 182. If you set your OBS on 180, you should have a 2 reading. 182. Although it's not part of the FAA's requirements, it's a good idea at this time to also check the course sensitivity. Turn the OBS so the needle moves to the outer dot on the indicator. The OBS reading should now be 10 or 12 degrees from when the needle was centered. Now, if your airport doesn't have a VOT, a radio shop may be able to provide a test signal for you. They don't transmit continuously, so you'll have to make an arrangement with that shop. The shop will also have to certify their test signal's radial accuracy and the date of transmission. You would do the check the same as if it were a VOT, except that you'll have to know what radial the shop test equipment is transmitting. It might be something beside 360. That same section of the airport facility directory where you found the list of VOTs also lists VOR receiver checkpoints, both ground and airborne. Ground checkpoints exist at many airports where the FAA has designated a place on the airport and certified that a VOR radial crosses there. For instance, at Dodge City Regional Airport, you would tune in the Dodge City VOR at 108.2 and look for the 150 radial at the center of the northwest end of the Northwest Southeast Taxiway. So you taxi to that point and center the CDI needle with a from flag. The OBS should read somewhere between 146 to 154 because the allowed error for ground checkpoints is also plus or minus 4 degrees. There is no regulatory requirement to check your DME, but you can check that it's within the normal tolerance. That's 1/2 nautical mile or 3% of the actual distance, whichever is more. That's why they also tell you the distance from the station, 5.3 nautical miles here at Dodge City. You can also check your VORs by flying over an airborne checkpoint at the stated altitude. For example, at Joplin Airport, you would tune in the Neosho VOR on 117.3 and fly over the approach end of runway 31 at 2,500 feet MSL, checking for the 344 radial. Just as before, center the CDI and note the radial. Since it's a little harder to tell exactly where you are when you're flying over a point on the ground, the FAA gives you an accuracy tolerance of plus or minus 6 degrees instead of plus or minus 4 degrees. What if there isn't a test signal or published checkpoint available? Well, believe it or not, you can create your own airborne checkpoint. Select a prominent ground point under the centerline radial of an established airway, preferably at least 20 miles from the station. Then fly over that point at a reasonably low altitude, one that's safe and legal, and see if your VOR indicates that radial. Again, you're allowed plus or minus 6 degrees. The final way you can check your VOR receivers is against each other. Obviously, you need 2 VOR receivers and they have to be independent of each other, except that they can share an antenna. This check can be done anywhere you can get good VOR signals, on the ground or in the air. Just tune both radios to the same frequency and use the OBS knob to center both needles to a 2 indication. With the needles centered, there should be a maximum of 4 degrees difference between the OBS readings. Now, even though this may seem like the most convenient method of checking the accuracy of your VORs, it's got a potential problem. The test may show the VORs within tolerance, yet they might not still be accurate. How could that be? It's unlikely, but possible for both VOR receivers to be inaccurate in the same direction. Your receivers could be within 4 degrees of each other and therefore legal by this check, but way out of tolerance if you did a VOT check or used a published checkpoint. So, whenever possible, using one of the other types of VOR accuracy checks is a smart thing to do. To recap then, the 4 types of VOR checks and their allowable errors are VOT with plus or minus 4 degrees, ground checkpoint also with a 4-degree error, airborne checkpoint with a 6-degree error, and the dual VORs with a maximum allowable difference of 4 degrees between the 2 VORs. Verifying your VOR's accuracy will do a lot for your confidence level. But there's one more thing you'll want to do for the FAA's confidence level, and that's to write down what you did. You'll need to record the following things: the date, the place, the bearing error, and of course you'll need to sign it in either the airplane's log or some other record. By the way, this does not have to be a permanent record. All you have to do is keep a record of the latest check. Now that you know how important it is to have accurate VORs, you should be aware that some electronic devices, like FM radios, can interfere with them. Since the FAA knows this too, they've created a rule about using portable electronic devices when you're flying IFR. You may not operate or allow anyone else to operate a portable electronic device unless it is in this small list of exceptions. And he's right, electric shavers is on the list. Hearing aids, portable voice recorders, and heart pacemakers, which I think is pretty nice of them, don't you think? The exceptions also include any other electronic device that you, as the operator of the aircraft, have determined in advance will not cause interference with the communication or navigation systems of the airplane. So, unless they meet one of the exceptions, items like AM/FM radios, cell phones, as well as TV sets and remote-controlled games may not be used during IFR flight, and that applies to you as well as your passengers.